Welcome to the math record. Today I'll cover integration using partial fractions. So basically sometimes functions could be broken down into smaller parts. So what we want to do is that we could integrate each of these smaller parts individually and then combine together. So let's try a simple example. So let's say we want to find the integral of 3 divided by x squared minus 5x plus 4. So usually when you're dealing with partial fractions, there's polynomials on the bottom, because those are easy to factor. So factoring the denominator, we have x minus 1 and x minus 4, 3 dx. Okay, so what we want to do from here is that we want to split them up. So come move this a little bit over. So we set this equal to the integral. So we're going to split x minus 1 and x minus 4. So now all we have to do is find the numerators. So, and then take the integral. So to find the numerator, there's a really cool technique called the cover-up method. So basically, whatever makes the denominator 0, whatever that value is, and then cover that number from the original, and then we're going to plug that in to get our coefficient. So for x minus 1, cover up x minus 1, and then x minus 1, when it's equal to 0, that means x equals 1. So 3 divided by 1 minus 4. 3 divided by 1 minus 4 is negative 3, so 3 divided by negative 3 is negative 1. So that means the coefficient for the x minus 1 is negative 1. Okay, what about x minus 4? So that means this makes it 4. That means we need to plug in 4. Cover up your x minus 4. So 3 divided by 4 minus 1. That's 3 divided by 4 minus 1 is 3. So 3 divided by 3 is 1. That means our coefficient for x minus 4 is 1. Okay, now let's take the integral of this. Well, this is the same thing as negative the integral because we moved the scalar out, x minus 1 dx. And this is just a reciprocal, so that means it's the negative natural log absolute value of x minus 1, close absolute value. Take the derivative of this. This is 1 over x minus 1. There's a function side, so we chain it. The derivative of x is 1. The derivative of negative 1 is 0, so 1 plus 0 is 1. So this is the same thing as this when we and then put our negative. So it's the same thing. Now we do the same thing with this one. So remember, this is just the same thing as this. It's just a different number instead of 1. So that means it's just natural log of absolute value x minus 4. And as usual, add your c. And that's it. Okay, let's try another example. Let's take the integral of 7x minus 17 divided by 2x squared minus 11x plus 5 dx. Okay, so we could factor this out on the bottom. So we probably have a 2x and a x because that makes 2x squared. So we have a 5 probably goes with the 2, and then we left with a negative 1. So negative 1, negative 5 makes 5. 2 times negative 5, negative 10. With this negative 1 makes negative 11. Okay, so that's correct. Equal to the integral. So split that up. So 2x minus 1 dx plus integral x minus 5. That's a little bit too high. X minus 5 dx. Okay, now what makes this 0? That's when x is equal to 1/2. So cover up method, plug in 1/2. 7 times 1/2 minus 17. 1/2 minus 5. So that's 7 over 2. This is going to be put in fraction form is 17 over 2. This is 1/2 minus 10 over 2. So that is negative 27 over 2. And this is negative 9 over 2. The 2's kind of cancel each other out. And negative 27 divided by negative 9 is 3. Okay, so we have a 3 as our coefficient. Okay, now we plug in x minus 5. So that means 5 will make the 0 cover up. 7 times 5 minus minus 17. Plug in our 5 here. So 2 times 5 minus 1. That's 35. 17 minus 35 is 18. And then that's 10 minus 1 is 9. 18 divided by 9 is 2. So that means the coefficient for this one is going to be 2. Okay, now let's take an integral of both sides. So move this out. Integral of 1 over 2x plus 1. 2x minus 1 dx. And this one is the 2 integral 1 over x minus 5 dx. And then 3 times the natural log of 2x minus 1. When we take the derivative of this, this is 1 over 2x minus 1. We have a function side, so we chain it. So the derivative of 2x is 2. The derivative of negative 1 is 0. So we're scaling this up by 2. But this, and we have a 3 here. But this is only 3 in the 2x minus 1 on the bottom. So we need to get rid of this 2. So we multiply by 1/2. So we multiply by 1/2. Let's put it right here. Okay. And then plus the integral of this. We have our 2 still. Integral of this is natural log of absolute value x minus 5. And when we take the derivative of this, this is 1 over x minus 5. And the derivative of x is 1. Derivative of negative 5 is 0. So it's the same thing as this with our 2 from the scalar. So raw, all we have to do is add a c. And if you want to simplify it, that's 3 over 2 natural log 2x minus 1 plus 2 natural log x minus 5 with those absolute values. And that is your answer for the integral of 7x minus 17 divided by 2x squared minus 11x plus 5. Well, thanks for watching, and in the next video, I'll cover integration of trigonometric functions.